Quadratic formula. What a nice topic. You know what makes it a nice topic? A couple things, actually. One, we're going to need it, right? But also, when you're doing this lesson, watch for the following points. When we're playing around with the quadratic formula, it gives me an opportunity to make several points. Like, for example, how should I say? Correctly substituting numbers in. Correctly substituting numbers in. And what I'm gonna emphasize is that when you plug anything into a formula, you should put it in parentheses. You'll see that come up. So I can do that. Correctly canceling things. And one of the points that's going to be made is if you have something like like an x plus 2 and that's over an x, for example, you would not cancel these x's. You do not cancel those x's, okay? And we'll get into a little bit more detail with that as we go. What else? There's other things. Correctly canceling, correctly substituting. And of course simplifying radicals. We need to be able to simplify our radicals, so we'll get a little review with that as well. We always want to express final answers in something called simplified radical form. And if you remember back from some earlier lessons, simplified radical forms has like 5-6 things that you gotta, like a checklist, make sure it passes all those things, and then you can say it's in simplified radical form. So anyway, keep an eye out for all these sub-points, if you will. Very important sub-points. But what do you say we get right into it here? What's the quadratic formula? Well, I'm going to state this in an if-then kind of a format. If this, then that. So much of math can be put in an if-then, really. So if you have something like this, what is this? This is it's called a quadratic equation. Quadratic equation. Some reason when you have an x squared term, and that's your highest exponent, when you have an x squared term, it's called a quadratic equation. What are you doing to me? Quadratic equation. And this one is in standard form. What does standard form mean? It means you kind of go in order, right? First you put the x squared term, then you put the x term, then you put the constant term, and make sure that it says 0 on the right. And by the way, a lot of times you'll have a quadratic equation and it's not in standard form. Well, your first task would be to just kind of massage it, rearrange it, and put it in standard form. So, of course, this a is just a coefficient, right? It's just some number. It's the coefficient, is the magic word, of the x squared term. B is the coefficient of the x term, and C is, well, it's a constant term. It's the constant term all by itself. So anyway, the A, the B, and the C are going to change, of course, from equation to equation. But if it at least follows this form, something times x squared plus something times x plus something else equals 0, then you've got a quadratic equation in standard form. And if you have a quadratic equation in standard form, then guess what? We already know what the solutions are, folks. Somebody already figured it out. The solutions are going to be x equals, take negative b plus or minus the square root, or radical, b squared minus 4ac all over 2a. And maybe someone has had you sing a song or something to remember that, or whatever. Be nice if you have that memorized. If you don't, keep it handy because we're going to need it. So there's the formula. So let's see how this gets used then. So here's example 1. 2x squared plus 3x plus 4. Well, that's a quadratic in standard form. That's cool. Now the a would be just the coefficient here, just the 2, right? The b is just the coefficient. It's just a 3. Sometimes I see people plugging in, you have a b here, right? So sometimes I see people plugging in a 3x. No, you don't plug in a 3x. You just plug in the 3, just the coefficient. So the b is a 3, and then over here the c is a 4, and we're ready to rock and roll, as they say. So I'm looking at the equation right there, or the formula right there. So let me just plug in referring to that. So I need a negative b. First of all, I need a negative. That's part of the formula. Put it there. Now I need to put the b. What's the b? The b is a 3, okay? So I'll put the b. The b is a 3. Fine. Plus or minus, radical. Now I'm supposed to put the b in there and square it, and I like to do this. Use parentheses whenever you plug in. So b is 3, I put the 3 in a parentheses, and then I square the parentheses. And then I've got this minus 4, and the a is a 2, yep, and the c is a what now? If c is a 4, I'm just glancing over here to get my a, b's, and c's. And that closes my radical all over 2 times, and the a in this case is a 2. Okay, cool. So all I did is I put all the numbers in their place. Now we should sort of boil it down. So I got a negative 3, I got a plus or minus, I got a, what's this now? 3 squared is a 9, minus 4 times 2 is 8, 8 times 4 is 32, so it looks like that, and that's all over 2 times 2. We're almost there, folks. So negative 3 plus or minus, now 9 take away 32 would be a negative 23, and that's all over 4. And finally, one of the points of simplified radical form is we're never going to leave a negative inside of our radicals. Remember, if it's a square root of negative 23, you can handle the negative quite nicely. All you guys will do is put an I in front. There, now it's a positive 23. Isn't that slick? That's just the slickest thing in the world. And here's your 2 solutions. Your 2 solutions. Now, that form is acceptable to me. If you're doing math on a computer, you're using ALEX or something, you've probably seen this before, but let's just emphasize, this represents 2 solutions. One of the solutions is, and I will use a curly brace here to sort of collect my solutions together into a nice little neat set. But one of my solutions would be, and what I'm going to do is I'm going to take this and split it up into 2 parts, negative 3/4 plus or minus I square roots of 23 over 4, like this. Oops, not plus or minus, I meant to say just the plus. And then over here, negative 3/4 minus I radical 23 all over 4, right? I'm just unadding the fractions together, so to speak. I mean, if you were to add these 2 fractions together, right, you'd say, oh, I have a common denominator, yay! You just add across the top, and you put it all over 4, right? So I'm kind of doing that in reverse. And now I got too much green, way too much green, way too much green. Okay. Actually, I should take this just one step further. Usually what you'll have to plug in ALEX or whatever, is you'd have to plug in, well, see this? I radical 23 over 4, that's usually written this way. You would write the radical 23 over 4, and you would put the I here, like this. Is that the same thing? Yeah, it's the same thing. Because if, I mean, look at it this way. If you were to multiply radical 23 over 4 times I, think of this as I over 1, then you would have the I radical 23 on the top. You'd have a 4 times 1 is 4 on the bottom. So yes, it is the same thing. So a lot of times they just kind of take that I on the, ooh, I want to get rid of the green. I wanted to get rid of the green. Blink. Let's put this back. Let's put this back in the right color. Okay. So anyway, yeah, they usually take this I and sort of have it jump off over to here. And then the other side, of course, would be negative 3/4 minus. And we do the same thing. We take that I and have it sort of jump off the shelf over to here. So these are sort of your ALEX solutions, or it's worth knowing. This is just another way of representing what I wrote up here. So negative 3 plus or minus I radical 23 all over 4. Again, I'm very happy with that form. If you want to split it up, that's great. But at least recognize that these are the same, right? These are the same. This means negative 3 plus, and this is your imaginary part, root 23 over 4 times I, and also negative 3 minus, blah, 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 blah. Okay, cool. So now I see that I need to shrink that down quite a bit. Let me just shrink this down and get it out of the way. I don't really want to erase it. I might want to look at this later. So let's not erase it, but let's kind of shrink it down. Isn't modern technology wonderful? Can't do that with pencil and paper. Anyway, now you kind of see how it works. We should do it again, because things are going to happen that we're going to have to make sure we can handle. The specific tactics of the situation change from situation to situation, so you have to sort of face it a few times, and then you get really good at it. Okay, so anyway, we got this other one. I guess the A would be 6. Notice the B would be -3, and the C here would be -1. So some of our coefficients here are negative, so that's a little different, I guess. But using the same formula, which is way off the screen, so let me just write it here. -b plus or minus square root b squared minus 4ac. That whole thing goes over 2a. Now, if I start plugging in, this negative is part of my formula, so I put the negative there. B is a -3, so I use parentheses to plug in a -3. Okay, plus or minus, radical. Now I'm supposed to take the b, which is a -3, and square it. And I'm going to pause to make an important point. Hey, use parentheses. If you don't use parentheses, if you write this, I'm going to say because. Why am I writing parentheses? Because this is actually not what you think, or not what a lot of people think. That is not 9. That is -9. And you can prove it to yourself if you get out your calculator. If you plug it in on your calculator, if you plug a negative and then a 3 and then you square, your calculator is going to say -9, because your calculator follows what's called order of operations. Order of operations says that first you apply exponents, so the 2 goes on the 3, and then you would multiply by anything. Think of this as like a -1 out front, maybe. This is like a -1 times 3 squared. What this is a -1 times 3 squared. The square is on the 3. It's not on the negative, is what I'm trying to say. It's on the 3, not the negative. If you meant a -3 being squared, you'd have to write it this way, or enter it on your calculator this way. And then it comes out to +9. Okay, because this is saying don't just square the 3, square the whole thing, square the -3. -3 times -3 is +9, okay? And I'm serious, get out your calculator, try this, you may be amazed. If you plug it in with the parentheses, you'll get the right answer. If you don't use the parentheses, if you plug it in this way, it's going to give you the wrong answer. So I emphasize, when you plug in, please use the parentheses. And if you write it this way, that's actually wrong. That's actually wrong. Even if you call that a +9, what you're doing is you're making 2 mistakes in a row. You don't want to do that, right? So there's my hey, one of my hey moments. So when you plug in, make sure that you're plugging in, you're using parentheses. Be very careful about that. Moving right along. Next I see the minus, so I'm going to put the minus. 4 times A is a 6, times C is a -1. Okay. This whole thing goes over. The whole thing goes over. 2 times A is 6. Okay, go. There, I plugged in. And I made a point about parentheses. Cool. So -3 is 3, plus or minus. Now you take a -3 and you square it, you get a +9. Over here, it says minus, but look, I'm multiplying by a minus here, so it's going to actually become plus. 4 times 6 is what? 24. And then that's all over. 2 times 6 is 12. So let's bring it over here. 3 plus or minus 24 plus 9 is a 33. And that's all over 12. And the good news is there's really no way to reduce that. There's no negative inside. I don't have to put an I there. And root 33 doesn't really simplify. So that's kind of it. That's kind of it. So if you were to write your answer like this, I would actually accept it. Now here's another point I have to make. P.S. What about, aren't we supposed to always reduce our fractions, right? Isn't that what we're supposed to do? Should I cancel the 3 into the 12 like this? If I do that, what would that look like? I guess I'd cancel the 3, right? So I guess I'd have a 1 plus or minus radical 33 over 4, like that. Do not do that, please. Do not do that. It doesn't work that way. I'll show you why it doesn't work that way. What this really says is it says 3/12 plus or minus radical 33 over 12. That's what it really says. So if you were to cancel 3's here, you can cancel them here, that's fine. You'd have a 1/4. But notice you're not going to have a 4. It's still going to be a 12. Okay? And actually this is an acceptable answer too, if you want to write it that way. But what you're not going to do is you're not going to do this. Okay? Don't just cancel like these two. You cannot just do that. If you were going to cancel, you would have to cancel here as well, because you've got basically 2 spots that you would need to cancel. If you're going to cancel 4's in both of them, you'd have to have something to cancel over here. There's nothing to cancel over here. You can't cancel the 4 anywhere over here. You can't do it. So don't do it. Okay? Never just cancel on a diagonal, I guess is what I'm saying. Is that what I'm saying? I think that's what I'm saying. And now I'm trying to get rid of some of this green stuff. Okay. I think I'll leave that because that's kind of an important point. I don't really want to erase that, although I am going to have to shrink it, aren't I? I know what I'll do. I'll shrink the whole thing. Let's try to get it sort of out of the way here. Oh, I love that. I just love that. Okay. So, I've made a point about what? Plugging in using parentheses. I've made a point about what? Make sure you don't just cancel on this diagonal like this. Okay. Well, what else might happen? I don't know. We should just keep solving and see what happens. What else are we going to see? Here's one. A equals 1. B equals -6. C equals -1. It's awfully nice of them to put it all in standard form for us, ain't it? Again, sometimes your first step is to make sure it's in standard form, but that's usually not too much work. So anyway, it's in standard form. Here we go. Let's plug into the formula. I guess I'll have to rewrite the formula again. Negative b plus or minus square root b squared minus 4ac. The whole thing over 2a. So I got a negative. The b is a -6. So again, with this negative is part of the formula, and then the b itself is a -6. Use parentheses when you're plugging in. Plus or minus square root. The b is -6. Make sure you write it like this. That becomes positive. Okay. -4 times a is 1 times c is -1. Okay, cool. So that's just plugging stuff in over 2 times, and the a is 1. Fine. Okay, cool. So I got a 6. -6 is 6, plus or minus. When you take a -6 and you square the whole thing, you get a 36. Once more, we got this minus, but times another minus makes it a plus, really, and it's just a 4, I guess. All over 2. So what's this? 6 plus or minus 36 plus 4 is 40. All over 2. So again, like I was just saying previously, we are not able to cancel those. We cannot cancel 2's into those things. You just can't do it because of this other term. This is like 2 fractions that have been combined. So if you can't cancel the 2 here and here, then you shouldn't be monkeying around with that at all. Unless you want to split it up into 2 separate fractions first, then you can cancel. But meanwhile, actually, we've got some work to do with that 40 there. We want to reduce the radical 40. We always want to reduce. How do you reduce radicals? One way to reduce radicals is to sniff out perfect squares. What are perfect squares? Numbers that you can take the square root, and it comes out even. Numbers like 4, right? Because the square root of 4 is 2. Numbers like 9, because the square root of 9 is 3. Numbers like 16, because the square root of 16 is 4. Numbers like 25, because the square root of 25 is 5, and so on. Those are the numbers. So you're looking at the 40, and you're not going to divide by 25, and you can't divide it by 16, you can't divide it by 9, but you could divide it by 4. So what you do is you think of the root 40 as a root 4 and a root 10 multiplied together, right? If you were to multiply root 4 times root 10, you would get root 40. Yeah, you would. And the reason we do this again is because it allows us to simplify this, because radical 4 is 2. And you still got radical 10. So it's 2 radical 10 is what that is. So moving right along here, we got a 6 plus or minus, and then this root 40 is becoming 2 radical 10, and that's all over 2. Now here, we can cancel 2's. We can cancel 2's because I can cancel the 2 here, here, and here, all 3 places. I can cancel all 3 places. If you can cancel all 3 places, it's legal. Referring back up to here again, we did not cancel those 3's because we were only looking at 2 spots, not 3 spots, right? There's 3 things. There's 3 zones, if you will. There's the 3, there's the root 33, there's the 12. There's 3 zones there. If you can't cancel in all the zones, don't cancel in any of the zones. Here I got 3 zones. I got the 6, I got this thing, and I got this thing. And I can cancel 2's in all of the zones. So I can cancel 2's. 2 goes in the 6 3 times. The 2 there will cancel. It's just a radical 10. And then it's all over 1. And I don't care about over 1. So there, it reduces to just this. And I would invite you, by the way, if you're still not quite comfortable with this, when can I cancel, when can't I cancel, one thing you can always do is split that thing up into 2 separate fractions, right? Split this fraction up into 2 separate fractions and then cancel in each one separately. So 6 over 2 is 3. And then here, obviously, these 2's cancel. And you're getting the same answer, 3 plus or minus radical 10. Okay, so I hope I'm making an important point about this cancel. Well, I am trying to make an important point, but I hope you're absorbing this point about this canceling stuff. Be careful with the canceling. When you have a 3-part fraction, what would you call this, a 3-part fraction? When you have a 3-part fraction like this, canceling is all or nothing. Everywhere or nowhere. Or again, you can always just split it up into 2 fractions, and then the canceling is a little safer. Okay, so once more, I'm going to have to shrink some stuff. Shrink yourself. What are you doing? You done been shrunk. Okay, cool. So, where are we here? Example 4. What could happen next? I don't know. Let's just see. A is equal to 1, right? B is equal to 2. C is equal to 8. Come on, pen. Okay. And I'm going to plug in, and let me just refer to the formula over here as I plug in. So negative b, but b is 2, plus or minus square root b squared, so that's a 2 squared, minus 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. So there it is. Now let's simplify it a little bit. That's a negative 2, plus or minus. 2 squared is 4, minus, and then 4 times 8 is what? 32. And that's all over 2. So I've got a negative 2, plus or minus. Now that's take a look at this. That's going to be a negative 28, right? Well, let's handle the negative right away. If you get the square root of a negative, all you really got to do is put an I in front, right? So I kind of, don't make sure you got that part, right? This comes out negative, and because it comes out negative inside, I put an I in front. Instead of a negative inside, I put an I in front. Okay, so I'm kind of doing 2 things at once there, which might be a little dangerous. And anyway, that's all over 2. Now comes the part where you need to reduce this radical 28, sniff out a perfect square. So just like the 40, it has a 4 in it. So the root 28 is kind of like a root 4 times a root 7, right? 4 times 7 is 28. And the 4 can be simplified, or the radical 4 can be simplified. Radical 4 is just 2. So that's really just a 2 radical 7. So what I got here then is I got a negative 2, plus or minus, and the 2 is going to come out, and I put it in front of the I, really, and I still got the 7 inside. And again, I made this point earlier, well, not earlier this lesson, but earlier in the course. Put the radical last, please. Don't write, try not to write this, 2 radical 7 I. And the only reason you don't want to write it that way is because it's just way too easy, especially at this, when you're working fast and stuff, is that sometimes your radical goes just a little bit too far. And if it looks like the I is inside the radical, that's obviously different than having an I outside the radical, right? So it's like you meant to write the right answer, but you wrote the wrong answer. That's not good to write the wrong answer, even if you meant to write the right answer. Okay, so anyway, put the radical last is what I'm saying. It's safer. Now, let's not forget that's all over 2. Hey, and we have a perfect example of the old cancel in 3 zones trick. Let's get a different color here. I can cancel the 2 because I'm canceling it not just here, but also here. If you can cancel everywhere, then it's safe to cancel. So I'm going to get, let's see, that's going to become a negative. If I cancel the 2, it's a 1, plus or minus 1i, radical 7. And then that's all over 1, and I don't have to write all over 1. I can just leave it like this. Cool beans. Those are some nice solutions. Straight line solutions. You gotta like the straight line solutions. Okay, just a couple more. Every problem seems to have a new point to make, doesn't it? This one has a point to make. The point I want to make here is, yeesh, that's the point I want to make. I'm talking yeesh. Look at this. Do you really want to go plugging these fractions into the formula? B squared minus 4ac underneath the square root. You want to plug those fractions in? I don't. I don't have to. You don't have to either. All you got to do is know the trick. What's the trick? That's a trick we've seen before. Remember when you got a lot of fractions in an equation and you don't like them? You want to get rid of them? You can do the old LCD trick. So first, looking at my fractions, and technically that's like a 3 over 1. Looking at my fractions, my denominators I should say, 2, 3, and 1, what's the LCD? The LCD is 6. So what I'm going to do then is I'm going to rewrite all of these fractions to have denominators of 6. So here I'll have to multiply by 3 over 3, right, top and bottom, to make that into a 3, 6 x squared. Here I'll have to multiply by 2, top and bottom, to make that a 4, 6 x. And then here, if I think of that as 3 over 1, I'm going to multiply top and bottom by 6 and get an 18 over 6. And then, yeah, you could say 0 is 0 over 6. And what you've done is you've made it all 6's on the bottom. And if it's 6's all the way across, that means you can basically ignore them. And so my equation is becoming this. 3x squared minus 4x plus 18 equals 0. Now, doesn't that look a little more friendly for as far as plugging into the formula? Wouldn't you rather plug in some whole numbers? I would. So remember the LCD trick. It can make your life so much easier. It wasn't that much work to change the equation, but it's going to save me a ton of work not having to plug fractions into my formula. Speaking of formula, what is that formula? Let's grab it again. Negative b plus or minus square root b squared minus 4ac. That whole thing is over to a, and it looks like this. Minus. Put the b in. Well, there's the b. It's negative 4. Plus or minus square root of. Again, the b is negative 4. Use parentheses, please. Minus 4 times the a. The a is a 3. Times the c. Well, the c is an 18. What are you going to do? C is an 18. All over. 2 times, and again, the a is a 3. We're looking at that. Okay, we should clean this up a little bit. A negative 4 is a 4, plus or minus. A negative 4, when you square a negative 4, you get a positive 16. And this will be minus, and what the heck we got here? 4 times 3 times 18. Well, that would be like 12 times 18. 12 times 18 is what? Let's see. 16, 9, 2, 1, 6, 11, 216. Okay. All over 2 times 3 is 6. Cool. 4 plus or minus. Now looking in here, 16 take away 216 is going to be negative, right? So I like to just kind of get ahead of the game and put my I in front. Just take care of the negative inside right away. The square root of a negative always just gives you an I in front, and then you don't have to worry about the negative anymore. So 16 take away 216 is negative 200. It's negative 200. So again, I handle the negative by putting the I here. And then that's all over 6. Okay. Quick point, you are not going to cancel 2's here, right? Nope. You are not going to cancel only on that diagonal because, again, you got a third zone over here. And if you can't cancel the 2 here too as well, then you're not going to cancel the 2 anywhere. So we're not going to cancel. However, we should really fix this. 200, that's too big. We need to fix that. Now you want to dig out a perfect square. And you could play with a 4, but think bigger. 4 is a perfect square, 9 is a perfect square. But can you think of something like maybe 100? 100's a perfect square, right? Square root of 100 is 10. So what I'll do then is I'll think of the root 200 as a root 100 times a root 2. Because root 100 is just regular 10 times root 2. So, okay, cool. So what do I got here? I got 4 plus or minus. And now the 10's coming out. I'll put it in front of the I. And then I'll have my radical 2 here at the end, all over 6. And finally, we can cancel now because we have the ability to cancel everywhere. So since I can cancel everywhere, I am going to cancel everywhere. So I'm canceling 2's. 2 goes into 4 2 times. 2 goes into 10 5 times. 2 goes into 6 3 times. So what have I got? I've got 2 plus or minus 5i radical 2 all over 3. There's my solutions right there. Pretty cool. Pretty cool. By the way, if you really want to, or if you're in some kind of Alex mood or whatever, you could split this up as 2 separate solutions like this. And it's probably worth another look. Make sure you can believe that. Make sure you see that. Make sure you could do it yourself, right? That's supposed to be a 2 inside, by the way. Okay, cool. So the fraction trick, the main point of this problem was up here, of course. The old LCD trick. Keep it in mind. You see a lot of fractions. Oh, it's painful. It's painful because, I pretty much always put a problem like this on the test. Pretty much always. And it's because I want to see if you remember the LCD trick. Or like if you ever saw in your life the LCD trick. Like, did you watch the lecture? You might have seen this, but remember it is part of the thing here. Make sure you remember that trick because it comes in handy. So, our last example, you should probably try this one yourself. You've seen most of the tricks, I think, as far as, the LCD trick, and you know how to reduce radicals, and you can do i's, and you're safe with the canceling, you're safe with the substitution, right? You should be ready to try this. Please try this. Pause. Come back. Okay. There's 2 ways you could tackle this problem. Well, there's at least 2. There's probably at least 3, maybe even 4. There's a lot of ways you could tackle this problem. But what I have in mind, following what I've been doing all along, is first I'll do the LCD trick. The LCD is 2 because this is like having over 1. This is like having over 1. So if I look at all 3 of my denominators and I make a common denominator, it's just 2. So I'm going to make everything have a denominator of 2. So this is a negative 1. How do you make a negative 1 to be something over 2? You make it negative 2 halves. 2 halves is 1, right? So 2 over 2 is 1, x squared. And then this is already a 1/2 x minus. Now again, this is like a 5 over 1. How many halves is that? That would be 10 halves. Times 2 times 2, you get 10 halves. Equals, and then you could write that as 0 over 2. The 2's are everywhere, which means the 2's are nowhere. So take the 2's out of there. Negative 2x squared plus just a 1x minus a 5. Whoops, what'd I do? No. If I take the 2 out, that's a 10, right? Right. Okay, like this. All right, now I better check myself. So yeah, there we are. So you can see your A, B, and C. Let's plug into the formula. I see the formula over here, so I'm going to sort of use it. So keeping my eye on that formula. Negative B. What's B? B is 1. Plus or minus square root of B squared. What's B? B is 1. Minus 4 times A, which is negative 2, times C, which is negative 10. Okay, this is interesting. All over 2 times, and then the A is a negative 2 again. So there's plugging in. There's plugging in at you, kid. Something like that. Anyway, negative 1, plus or minus. Radical. 1 squared is 1. Okay, lots of negatives here. So negative times negative is positive, but then I get another one, so it's negative. So it's minus. 4 times 2 is 8. 8 times 10 is 80. Okay, and that's all over a negative 4. So as I got here is I got a negative 1 plus or minus, and 1 take away 80 is a negative 79, I guess. All over negative 4. So it's negative 1 plus or minus, and I really should put the I there. I radical 79 over 4. Now can 79, can we divide it by a 4? No. Can we divide it by a 9? No. Can we divide it by, anything that's just, no, we can't. I think it's a prime, in fact. I don't think you can divide that by anything. So negative 1 plus or minus I radical 79 over 4. Now like I say, if you want to, you can circle that and call that your solution. Oh, wait a minute. Hold the boat. I made a little mistake there, didn't I? That says negative 4. Whoa, Nelly boppers. That's a negative 4. Okay, don't make mistakes like I do. No, you don't want to make mistakes like I do. Don't make mistakes. So anyway, okay, so this isn't done. Why isn't it done? Because one of the things you never ever want to do is leave a negative in the denominator. U, that's a capital, no, it's not really capital. It's an EW for U. U, don't do it. Don't do it. Why wouldn't you do it? Well, consider if you had something like, I don't know, just make this up, 1 over negative 2, right? Isn't that really the same as negative 1/2? It is. First of all, if you divide a positive by a negative, you get a negative, so you know it should be a negative result. But, I mean, this is just so much nicer looking. This is proper over here. This is good math etiquette, good math hygiene. I don't know what you want to call it. It's good for you. Write it that way. Please do not leave a negative in the denominator. It's so gross looking that I deduct for that. So please don't do that. So that means please don't do that. So what are we going to do here? What are we going to do? Well, the safest approach, I suppose, would be to split this up into 2 fractions. So I got a negative 1 over negative 4, plus or minus, and then I got the radical 79 over negative 4 times the I. Because if I split it up into 2 fractions, now I can see what's going on with the negative. First of all, over here it's canceling. That's just a 1/4. What's going on over here? Well, I'm going to say this. I'm going to say, I'm going to bring back what I was saying before. If you had 1 over negative 2, you would just put the negative in front, right? Just hop it in front. So this negative, I'm just going to hop it in front. I'll have to use a parentheses, I guess, but hop it in front. And now I've got my radical 79 over 4 times I, like this. Okay? Now, here's the thing. This is definitely a 1/4. Now, this is interesting. A plus or minus times a minus. What does that do? Not a lot. Because this is saying 2 solutions. Take the plus times the minus and you'll get a minus. But if you take the minus times the minus, you'll get a plus. So I've seen people write it this way. Minus plus. You don't have to write it this way. You could just say, well, it's like nothing happened. it's still plus or minus. Radical 79 over 4. I like this. And then if you want to put it back together, you could say 1 plus or minus radical, 1 plus or minus, 1 plus or minus I radical 79, the whole thing over a positive 4, which is better. Not a negative 4, a positive 4. So this is kind of gross. So I'm going to write U. That's a little bit gross, having a negative on the denominator. If you compare this to this, which one looks better? This one looks a lot better, especially if you make your 4 look right. This one looks a lot better. So please, no negative denominators. So I think I said I was going to solve this 2 different ways. I'm not actually going to solve it a second way. I'm just going to make a point about what you could have done. So this is all the theories of negative denominators, I guess. But if you come back up here, right, what I could have done is in the same way that we said, hey, make the LCD a 2, and then we got to here, right? Well, what you could do now, if you wanted to, is you could say, hey, why don't I just multiply, I'm going to say could have, just multiply everything by negative 1. So that becomes a 2x squared, that becomes a minus x, that becomes a plus 10, and a negative 1 times 0 is still a 0. Right? I just change that sign, change that sign, change that sign, and 0 doesn't really have a sign. So 2x squared minus x plus 10, it's an equivalent equation. And if you solve this one, you don't have to worry about an a being negative. You won't have to worry about having a negative denominator. You won't even have to worry about any of that stuff. So there's a good trick. Another good tip. So actually, you'll see me do this a lot with a lot of different equations and expressions and stuff, is when I have a negative in front, I usually like to kind of get rid of it. If it's an equation, you can simply cancel it. If it's not an equation, you'll see me factor out a negative 1, but that's later. So anyway, in this case, you certainly could have just multiply the whole equation by negative 1, and then you don't get a negative a, which means you don't get a negative 2a, which means you don't get a negative denominator, which means you bypass all of this interesting stuff down here. As interesting as it is, sometimes you just want to be efficient and bypass it, right? Okay, I think that's a pretty good handling of the quadratic formula. Hopefully you're ready to go, and you're going to be fearless at applying that thing in our, solving our polynomial equations and such. Good.